Good morning, everybody, or afternoon, or evening, whatever time of day you're watching this. As you know, we are home, and I don't really know how long this is going to be, so I want to make sure that I'm able to teach you exponential functions, um, because math is hard to teach yourself, and I recognize that. So I want to make sure that we're all on the same page and that you are able to do your assignments successfully. So, exponential functions. What is an exponential function? Before we even do any of that, I want to go over some things that you're going to need to know for this lesson. Things that you've done in the past, but I want to make sure that you remember how to do this. If you are my student, that means that this looks awfully familiar to you because this is how I teach in class. So, prerequisite knowledge, how to convert percentages to decimals or decimals to percentages. So if I have something like 25, or let's start at the most basic level, 50%. 50% is half, right? So I know 50% is going to be 0.5. Now, how do I convert this? 50, if I take 50, that the decimals at the end, basically, and we've gone over this in class, but percent means per, and cent in French means 100 for my Haitian and French people. So per cent, that means per 100. So if I have 50 per cent per 100, so 50% is equal to 50 per 100. That's a ratio, 50 over 100. That is the same thing as saying 1 over 2, which is 0.5. Now, what we've done in the past is when you are dividing by 100, so if I have 50 over 100, I can take so if I have 50, I could take the decimal place and move it to the left because I'm dividing by 2, and I'm going to get 0.5. So all you got to do is move the decimal place of 50 over 2. So if I have 25%, I take my 25, I move the decimal place over 2 places, and I get 0.25. This is 0.5. If I have, let's say, 68% is equal to, again, let's do some color coding here. I take my decimal place, I move it 2 units, and I get 0.68. Now let's do a little bit more difficult ones. If I have 4%. Now, I have a decimal place here, right? Because if there's no decimal place, it's at the end. I move it 2 units, and what do? Is I put a 0. I fill in my little circles with zeros. So I have 0.04. And then a little bit more difficult is what if I have something like 100%? 100% is a whole, so it's going to make sense when I move my decimal place 2 places. It's just 1.00, which is just 1. Or, let's make a little bit more room. If I have 112% and I move it over, here's my decimal place, I move it here, and I have 1.12. So what about going the other way around? What if I go the other way around? So this is from percentage to decimal. Well, guess what? If we go, let's put this here. If we go from decimal to percentage, it's the same thing, just the other way around. So if I have, let's go backwards. So 0.68, what is that as a percentage? That is, and I just, instead of going to the right or to the left, I'm going to go to the right. So I'm going to take my decimal place and I'm going to go to the right. Basically, I'm multiplying it by 100. And so I get 68%. Or if I have 0.05, 0.02, I move it to the right, and I get 2%. Or maybe a little bit more difficult problem, if I have 0.0085. Now I take my decimal place. Again, same thing. I move it over 2 places, and I get 0.85%. So, yes, you can have a decimal percentage. It's going to be a very small portion of the number, but it is a decimal percentage. So, there you go. That is the prerequisite knowledge. Now, let's go over some words that we need to know. If I have, let's say y equals, actually, let's just do 2 times, let's go 2 to the x. Or let's go 2 to the 5th power. 2 to the 5th power is the same thing as me saying, so let's say 2 to the 5th is the same thing as me saying 2 times 2 times 2 times 2 times 2, 5 times. Because of that 5 right there, right? So I have 2 5 times. So you are multiplying each and every single one of these. So when we have something raised to a certain power, there are 2 words for that. It is called either the base, so the base of the exponent. So it is the base because the exponent is being raised to that number, or the base is being raised to the exponent, or it's called the multiplier. The reason it's called the multiplier is because, for this reason right here, it is every one of these is being multiplied by each other. So it is the multiplier because multiplication is the operation of exponents. You are not multiplying 2 by 5. You are multiplying 2 by itself 5 times. That is important. You are multiplying, I'm going to write that down, 2 times itself 5 times. Not 2 times 5. Okay, so that is the base or multiplier. Exponent. We've gone over this when we went over like quadratics and stuff. So exponent is the number that it is being raised to. So 2 to the 5th. So basically the exponent is the number of times the multiplier is being multiplied by itself. I know, so many words. Now, coefficient. The coefficient exists only if you have another number here. So if I have like 3 times 2 to the 5th, that would be the coefficient. Okay, so here's what's important with the coefficient, the exponent, and the multiplier. If I have, let's do this, 3 times 2 to the 5th, which is exactly what we have above. PEMDAS, or the order of operations, or GEMS, or whatever you've used in the past, tells us that 2 to the 5th power, it comes first because it's exponents first and then multiplication, right? So again, PEMDAS tells me that exponents come first and then multiplication. So what I'm going to do is I'm first going to do 3, and then I'm first going to do the 2 times 2 times 2 times 2 times 2. And 2 to the 5th power, you can either do it out. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Or you could put it into a calculator. I'll show you how that works. So if I do 2 and I go to the 5th power, it's 32. So I would do 3 times 32. And 3 times 32 is 96. Okay? What you will not do, I'm going to put it here, not, and this is a big mistake a lot of people make. You will not do 3 times 2 and then to the 5th power. So a lot of people think that they can multiply this 3 and 2 together. You cannot do that. So you cannot multiply these together. You have to do this first. That 3 just comes down like any coefficient. So this, you do not do 3 times 2 first, which then becomes 6 to the 5th. And 6 to the 5th is a much larger number. Let me show you. 6 to the, let's see, to the 5th power is 7,776. So 7776. You'll see you do not get the correct answer. Okay? This is not what you do. Bad. Okay? I'm emphasizing it because it is what people do a lot. Okay. So let's talk independent and dependent variables. We've talked about this a little bit in the class, but an independent variable is the variable that doesn't depend on anything. So that is going to be your x, and your dependent variable is the one that's dependent on the other, and that's y. So y is dependent on x. Whatever x is, y becomes. Okay? So if I have a problem like this, y equals 5 times, or I'll put them in parentheses, 5 times 8 to the x, I can label each and every one of these. So I know y is my dependent variable. I know 5 is my coefficient, which we're going to talk about also what it is later on, because there's another name for that. 8 is my base, but it is also my multiplier. And x is my exponent, and it is my dependent variable. No, independent variable, I'm sorry. Okay, so vocab. You know how much I love vocab. I know you've missed me. Okay, what is an exponential function? So now we're going to actually define it. If I were you, I would be taking notes. I cannot be there with you, so I cannot make you take notes. However, I would highly, highly emphasize, highly recommend it. So what is an exponential function? An exponential function is a function whose independent variable, x, is the exponent. So we did it up here. The exponent is the independent variable. So x is your exponent, or t, or whatever your independent variable is. So it's really important here. Your independent variable will not always be x. It could be t. It could be f. It could be m. It could be any other. But it's basically when you're talking about exponential functions, your independent variable is going to be whatever your exponent is. Versus a power function. So here, exponential function has the word exponent in it. So it's important to note that your variable is your exponent versus a power function whose base is a variable. So we've done this. So a quadratic function is y equals x squared, where my independent variable is my base. So my base is my independent variable. So it's really important here that the exponent is your variable. Okay, so let's look at what this looks like on Desmos when we graph it. So here's y equals b to the x, any number. So my a value is 1. That's what that means. A is 1. So if I put a 1 here, it doesn't change anything. My a value, or my coefficient in front, is 1. Okay, so we usually use b for base for pretty obvious reasons, right? B for base. And we are going to be moving this around. So I'm changing my b value. So right now, this graph right here is y equals 2 to the x. When we get to graphing, I'll explain why this goes lower and lower and lower. But for right now, it's more important for you to focus on the rising, not the declining. Okay, so the question is, what happens as b becomes bigger? So as my base gets larger, what is happening? The answer is that it is growing at a faster rate. So look, here, let's go back to 2. Versus a linear function grows at a constant rate, right? So if I look at this and I put y equals 2x, or let's do 2x plus 5. So we have a linear function and it grows at a constant rate, right? Versus an exponential function, it grows at a exponential rate, meaning we have 0, 1, but then we have 0, we have 1, 2. It's not exact because I can't get it there. There it is. 1, 2. And then we're going to have 2, 4. And then we're going to have 3, 8. Right? So it grows at a quick rate. Okay? As I increase, it grows at a quicker rate. It's like a roller coaster, right? The roller coaster's still growing, but this is King Dakar versus this right here is some baby roller coaster, right? It's a lot, or that's not even, this is more like the baby roller coaster, right? So it's what's important here is that it's still growing, right? As it gets bigger and bigger and bigger, it's still growing. But what happens as it gets smaller? So I want you to focus on this number right here. Actually, I'll say it. Look at the graph. So I have 1.3, 1.2, 1.1, 1.05, right? It's still growing. It's growing at a very smaller rate, but it's still growing. But look, it's still going to grow. But the question then becomes, what happens as we move past 1? So we get to 1. If we get to 1, it's a constant line. It's not helpful at all, right? This is not an exponential function. B cannot equal 1. It is no longer exponential. However, what happens when it gets smaller than 1? Look what happens. It goes from an increasing, right, exponential growth to exponential decay. Okay? So that means it's getting smaller and smaller and smaller as x gets bigger and bigger and bigger. So it's really important to know, okay, when the b value is less than 1, but still greater than 0, because look what happens. It's getting smaller, but it's decreasing at a quicker rate. 0 is not a function, but look, when it goes into negatives, the function legit disappears. It's not there because it cannot happen. Okay? This is so crucial here. When b is negative, it is not non-existent. When b is 0, it is non-existent. And when b is 1, it is non-existent. But when it is between 0 and 1, it is decay. And when it is greater than 1, it is growth. Okay, so I'm going to go back to my notes. So this, because b is equal to 2, which is greater than 1. So therefore it is exponential growth. Same thing here. B is equal to 3, which is greater than 1. So therefore it is exponential growth. But here's the thing. This one grows faster because b is greater. So because I'm going to write because b is larger. Okay, what about this one? So b is equal to 1.1. Is that greater than 1? Yes. So it is still exponential growth. But it grows slowly. Okay, that's really, really crucial here because your whole entire assignment is about this right here. Okay, but what about this? B is equal to 1/2, which is less than 1, so it is exponential decay. It is decaying. Here also, B is equal to 1/4, which is less than 1, so it is exponential decay. And also here, this is B. Is this greater than or equal to 1? It is less than 1, so it is decay. So let's recap here. Exponential growth is when B is greater than 1. The larger b is, the quicker it grows. And then exponential decay, when b is in between 0 and 1. A lot of times it's either a fraction or a decimal, but look here, if you look at this, this is also a decimal, but it's still greater than 1. So you have to keep in mind what each number is. And then for decay, so I'm going to put it like this. The closer it is to 0, so it decays faster to decays slower. So the closer it is to 0, so I'll put closer to 0 and closer to 1. So you can even see that here. If b is 0.1, you see it's decaying at a really, really fast rate, versus when it was 0.9, it's decaying at a very slow rate. Okay, so I'm going to go over this in a separate video because I don't want this one video to be too long. So like and subscribe to my channel.